Hello and welcome back. Um, Hello again and welcome to the stream. Usual stream implementing a research kind of programming language in Rust with an aim to in future develop it into a uh, kind of a domain specific, like a general purpose domain specific language for scripting, and essentially hoping to replace Bash scripts with a more structured approach, but keep the ergonomics of Bash that have made it so useful over the years. In today's episode, so basically continuing on from last time, which was last week, I believe, where I finished up. Like I left at the last few minutes because I was having trouble with one particular. Oh, I was showing off the method called syntax. So what I'll do, and I was running into some problems there. I basically, as soon as the stream finished, I kind of copped on to what exactly was going wrong. So I'll hopefully resolve the error I was seeing from last week quickly enough. Then I'm hoping to maybe take a look if it's not too difficult, maybe take a look at finally um, making the errors that we're getting a little more digestible. So, for example, at the moment, when we get an error, uh, so we can see from last week's or last time's stream that basically I'd run into this error, and so if I save that as is, and I take a look at the output, um, the error is the issue is a token error basically, but instead of giving us a line number and column, we get basically just a column as if the whole script was on one line. And what I've been doing to debug is just putting everything on one line and actually going to the position that the error is at, but hoping to resolve that, or at least take a look at that today, see if it's not too tricky. Then I might see if I can add some bit of um, extra information there. And then what I'm demoing at the moment, so yeah, I suppose I'll go back to what's the current code, and it's basically to show off the kind of closure mechanism in this language that's there so far. So the example is using the example of a set. So we create a new set here, and the actual data for the set is defined basically in line, and then a closure is created around that data so that the object that's returned is modifying the value from that scope. And then down here, the theory is that we can modify the data using these calls. Now, there are a couple of, even aside from the error that we were getting, which is essentially because at the moment function calls, so basically big explanation of what was happening. Function calls here, I was trying to use them as expressions, but so far I hadn't actually defined them as expressions thus far. They are values in the language, so they are first-class citizens, but they're not expressible in the syntax of the language, in the structure of the language as expressions. They can only be called as statements. So so basically, I just need to add support for functions in function calls in the expression section of the language, and that should resolve that, hopefully, fingers crossed. And then there are a couple of things I'm hoping to get through today, but I'll probably focus almost mostly on this example where I might hopefully update this syntax or give it a more lightweight alternative the same one that's in JavaScript, which is that if we have a an identifier conforming to the rules of the language, then it can be used as an alternative to the kind of method or the indexing syntax. So it's the same. It'll resolve the same under the hood essentially, but it's just an alternative syntax. And in this language, again, even though this is just a research language, it won't be, I hope, used for any production purposes. But just to clarify the distinction between when the two should be used, because I feel like I haven't anyway come across much discussion on when to use one over the other. I suppose people tend to just use what works, or perhaps more experienced people have a particular structured approach for it. But the, shall we say, the idiom in this language will be that essentially if objects in this language, similar to JavaScript, are fulfilling two purposes. One is to encapsulate structured data, so we're using them for actual objects as we would in Java and so on. But then the other half of the use of objects is to be used for dynamic data and dynamic usage, where the fields are defined at runtime, in which case it's effectively being used as a hash map. And the fact that it's used as both is actually really nice, because it means that we get essentially this really nice reflection mechanism. It's effectively for free, and it kind of flows quite well in the syntax of the language, and you can do reflection very easily because you're accessing fields the same way as you would access keys of an object. Versus, say, I don't know, even something like Python, where you know uh, an object is one thing and a dictionary is another thing. And if you wanted to access attributes of an object or an instance of a class, then you have to use these specific built-in functions. So having this shortcut is nice, but I do find that that certainly isn't clear to are made clear to junior developers, or even mid to senior. In my experience anyway, I've never really seen reference of this. So just to make the distinction and to say, you don't just use stuff ideally ad hoc. You would have a somewhat of an idiomatic approach, which would be that if you are using an object in or yeah, an object as an object, then you would use effectively the object syntax, we could call it. Then if you're using the object as a a dictionary or a hash map, then you use it as you use the kind of indexing syntax. And finally, if you are using reflection with an object, then you would of course be using the lookup syntax as well, because that's the only way you can do it. But with that said, yeah, so I'll be basically adding that that shortcut syntax today, hopefully. Also planning to add support for the this shortcut, which will basically allow us to create objects in this way, but without basically at the moment the only really way to create objects or create classes, so to speak, is to use this kind of closure approach, where you create the data, or you create your the data of the object in some kind of constructor function, and then you return a list of methods that act on the data. As an alternative, I'll be looking at supporting a this construction so that the values could be defined on the object itself, and then the this keyword can be used in other functions of that object to reference the other fields or other fields and methods of the same object. So those are some of the things I'm wanting to do today. In addition, if they're quick, I might look at being able to iterate over the key value pairs of an object, and potentially looking at doing sublists using the special notation that Java Python and Golang use. So with that all said, just going to get stuck in. So first thing I want to do is take a look at this issue from last time, which was that expressions or functions aren't expressions yet. And I believe the, let's see, what's our best way of doing this? So we can have, so this is, so basically what I'm wanting to do is put this in the same section as the indexing operator. So at the moment, the way functions are called functions, well, it's not that they have to be statements, sorry, it's that like the end effect of this is the same. They are expressions, but they have to be called in a statement-wise way, i.e. they have to be a name followed by a list of parameters. Whereas I'm going to move this next to wherever the indexing operator is. So I was just looking there, and those are actually not, that's not the indexing operator, those are the list and object literal operators. Where the indexing operator actually is here. Yeah, and so, oh, what did I grab there? Did I delete the wrong thing? Okay, I'll grab that anyway. Yeah, so there we go. And essentially I'm going to now replace that with an expression. So now an expression followed by a parameter list will be evaluated as a call. And so hopefully that should be enough to get this above example working. Now, I did highlight last time that these will error because we don't, the language doesn't currently have a, oops, so I need to update some bits. So in ASD, yeah, so there'll be some updates to the evaluation, of course. Yeah, that makes total sense. So I call the function now will be an expression that'll have to be put in a box. Box new func, and the evaluation rules will need to be updated as well. But basically, the language currently doesn't have a mechanism for essentially doing a safe lookup. Maybe I should add the Go style kind of value plus OK as a workaround. That would probably make the most sense, and it would still allow support for this feature. It wouldn't have the nice shortcut where you could, not that it's necessarily a nice shortcut, it's probably, I suppose I have my own views on it, where you can default to panicking instead of, I mean, that's what I'm doing here. Like, even though I say that, that's what I'm doing here. But it'd probably be nicer just to have some kind of an OK mechanism for for looking up values. So first of all, I'll fix the call anyway, and so that's what I'm being told about over here, I assume. 798 expected string found a box. Yes, so that's changing now. So instead of looking up the function, I'll actually be evaluating. Let's see, do we have any examples elsewhere of just evaluating expressions? Yes, we do. Or is there an easier one? And maybe in the index. Ooh, it's a big block. So where was I? I should relearn to use marks. So where was I? I was at call. And instead of that, I'll have eval expression. And maybe I'll call that expression as well. I'll have to rename that in the parser. And so if it's it has to be a func f can only, so it'll have to be call functions. I'll close this. This could be a little tricky because there is a lot going on in this particular section, being able to handle built-in functions and user-defined functions. So let's see. So the values are evaluated, or the arguments are evaluated first. Maybe I should evaluate the function first in time, so that we find out if it's even a function before we try to evaluate its arguments. But anyway, so I'm evaluating the function expression there. If it is and so I essentially need to replace, where did that come from? There. Yeah, so that that'll all be like that. And let's let v from down there. And that should be it, hopefully. Yes, okay, so and actually that's the output I think we were expecting. So yeah, so that actually might be just done now. So first of all, the functions are still working as before, even though we updated exactly how they're being evaluated. So at the kind of syntactic level. So before it had to be an identifier followed by a parameter list. Now it's actually, this is essentially a variable that's being looked up in the current scope. And then it's discovered that it is a function and we're doing a call on that function that was just evaluated. Then, and now because we have functions are actually proper expressions, well, there were expressions before, but functions now can be, or a call can be made on any expression now, excuse me. So now that a function can be called on any function expression, then these two statements work. So we've set A and B in the context, or so basically we're creating a new set called x's. We're calling the set method on x's, so we're setting A and we're setting B, and then first of all we're printing, oh, does x's have A, and we're getting true, but then we're saying has it C, and at the moment we don't have support for, basically if a lookup fails, then essentially a panic happens, or what's effectively a panic or an exception, where it's saying, you know, that that value wasn't found in this object. So maybe what we'll do first, and again, it's one of these things that the list keeps growing longer, but for an object, allow non-panic lookup using, for example, v OK is equal to x's abc. And before I get onto that, I suppose I'll commit what's there. So we've refactored functions to be like that, or calls to be allowed to be called on function expressions. Oh, 51 characters. Allow calls to be done on function expressions. Yeah. So that's that done. The next iteration of this will be this should be just a runtime thing. It is changing the behavior of the language itself, but where is test.txt? So it'll be, how's this defined? Index. So we have, yeah, it's in index. So an object prop. So for both of these, this will use a similar mechanism to what we're doing in the loop definition, where we create a new value. And the idea here is that, so here we go, index must be an integer. So is this just in assignment? Yes. Okay, so that's not fully handled yet, but anyway. So I'll take a look at index retrieval. And so what have I got on my clipboard? Oh yeah, the new entry. So essentially, ooh, this is getting quite deep again. The code here is very messy indeed. but essentially what we're going to do here is if the index is out of, we're going to return data regardless of whether something was found. So instead of returning an error, so I'll be defining this for lists and for objects. Maybe I'll just do it for objects for the time being. Because even though to be atomic or to be safe in the face of atomicity or concurrency, realistically, I would allow this kind of atomic retrieval operation, because if I were to allow, or if I were to say, okay, you have to check the length of a list before you check the index, then that could be subject to time of check, time of use issues. So just to be a good citizen, I will do it for lists as well. Only thing is, this will probably be ignored more often than not, the boolean that's paired with it, but that's okay. So the new entry that will be returned will be in the case of something actually being found, it will be, oh, this looks so bad. It's just so deep. How many levels of indentation do I have here? I'm actually just going to count this. This is kind of mental. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then another 2 there, so 15 levels of indentation. Just for everyone's peace of mind, this is the kind of work in progress development branch. When I'm working on the main branch in the future, hopefully, I will be intending to have these way shorter. This is kind of one of the reasons I actually typically use a column width of 8 characters, or a tab width of 8 characters when I'm writing Go, just to prevent massively nested areas like this. I find it's a little trickier to do that in Rust, so I find that Rust I'm less able to kind of split things out quite as much as I'd like, and so it just tends to be more pragmatic to have this kind of tab size of 4 characters, but yeah, it's not without consequences. Anyway, so new value reference, that'll be a list, yeah, same as that, except the value here now will be the v. So instead of the OK, returning OK here, it'll be return new value ref. Will I have to clone v? Probably, but I'll just make the compiler confirm that for me. And then this will be a new val ref as well, and it'll be a bool b, and it'll just be true to say that, yep, that stuff was there in that spot. And then instead of panicking, this will just be saying false. Whoops, where are we going? And then the actual value paired with it will be null. And then same procedure with objects. Yeah, exact same for the none case. In the case of some, however, we will be getting, in fact, yeah, that'll be the same for both. So let's see how that works. Yeah, so I do need to clone that, as may have been expected. And so I've one remaining error, it looks like. Oh yeah, so I'm actually, again, I really shouldn't be, well, I can, could tidy that up a little bit. Let pair is equal to that. Kind of breaking some of my style rules here, but again, the style of the project at the minute is probably a little worse for wear anyway. So it's probably not the biggest issue. Anyway, X's here will be the pair. And then I'll actually do the same thing for and the only thing that will change here is then we'll use props get name instead of that thing, or instead of the indexing. And then with that, can only call functions. Where is that coming from? That's very interesting. So if I print one, is it presumably happening on the new function, or on the it's probably okay, interesting. So oh dear, yeah. As expected, the first victim of this update is yeah. So that's not going to work really. Whoops. So it should be. I'm not quite sure why that's failing. Print 2 and the value of set 0. because essentially what's happening is I would have to look up the set function as that, and then call set a. But what's going on here? So the second function, or the second item in that list is, excuse me, is a function. Yeah, data func, and the argument k. Not sure why I can't then call it. Okay, I'm able to call it with that syntax, but if I okay okay, so oh dear, yeah, so so I can call it with this syntax, but then when I index the 0th, so as a shortcut of doing this pair, I was saying, oh, I'll just get the first value of that pair, but this then creates a new list which I'm indexing. Yeah, that's not really going to cut it. Anyway, I'm just going to get a charger just there for the laptop, but that's yeah, realistically for this to work the way it works in Go, there would have to be some kind of, yeah, probably syntax level distinction between the the lookup and whether it's being done kind of, you know, whether it's meant to be returned with the sentinel value or not. Whereas we're always returning the sentinel values, which means that it's being returned in a list or a pair. And so we're running, well, I'm running into issues. So yeah, I suppose I'll just discard that. So yeah, that was worth a shot. Didn't quite work out. It was a bit of a spontaneous attempt anyway. So what I'll do next is look at this lightweight or lighter weight syntax for method calls. So let's see, and what I could do, you know, just to, like, I could support some kind of explicit syntax to say, okay, turn this lookup into a into, like, basically tag the operation or something, so that it's saying, okay, if this you know, if this is a lookup, then turn it in, you know, return a pair if the lookup was unsuccessful. Otherwise, or sorry, if it's a lookup, then always return a pair, which will hold the sentinel value in the second position. But yeah, I'll leave it for now. So what I will focus on is this new syntax. So it'll be there next to call, no, next to the key lookups. Now where, oh, maybe I don't have anything defined for that just yet, actually. So yeah, so this will be the first example of this concept. So just looking up values via basically, yeah, looking up properties. So should I call them attributes or properties? I'm not sure. But anyway, so this will be an ident, and yeah, I'll just call them properties for now. And even though, is JavaScript like one of the only language, well, not only, but most other languages would call these attributes, even in databases. These would be typically attributes. Yeah. Or you can just call it a field. Yeah, I'll call it attribute, I think. For now, it's not like it's famous last words, but this shouldn't be of any great consequence anyway, to just call it attribute here. So an expression could then be an attribute lookup, and the name would then be a string, and to evaluate that then will be it'll just be the same as an index call on an object. In fact, I should be able to use the exact same code. So remove the support for lists in that section, and then instead of location, we'll have name. And oh yeah, and so this is, I'm adding support for this somewhat accidentally. It seems like it was that was easy enough. I'll have to confirm it in a little test, but I can only assign to attributes of objects. But basically, so this will be the implementation of that for assignment, and then I also need to do it for kind of retrieval. So again, remove that. And this will be name instead of location. Property name must be a string. So oh, that's one area of difference, is instead of so first of all, there's the expression, and then the location would usually be an expression as well, but that's, so instead of having a match there to look up the string, it's instead we don't have to evaluate that. We can just retrieve it, and that didn't have any error handling around it before, so that should be all right like that. And then similarly here, I'll separate these sections out, then match. That isn't needed anymore, I don't believe. Oh, I've got this called property everywhere else, so no, it's too too late to call it an attribute. Oh, I've duplicated index, have I? Yeah, that should be prop. And AST. So much for all my goodwill. Anyway, that should be sufficient to implement that. I'll have to check the assignment version as well, which I hadn't thought of here, but should be all right. Yeah, so that's basically working away as before. I'll just comment out this line and it. Why is it rebuilding? I feel like Vim sometimes just touches files, even if you don't modify them, so that it causes a recompilation. At least that's what it seems like sometimes. But I should be able to change all of those to the new method syntax now, and have the operations stay the same. Okay, I didn't touch anything there, and it still was rebuilding. Not sure what the reason was for that. But yeah, that seems to be implemented now. What else must I do? I must also check the functioning of. I have the increment operator, don't I? But I must just check the operation of setting to object fields. So plus or equals doesn't seem to be supported. So is it not? It's only supported for when there's an identifier on the left-hand side. That is something I should probably rectify shortly as well. Unrecognized token plus. Oh dear. It could be something similar. First, I suppose I'll remove that for the time being and just see what happens if I do regular assignment. Okay, regular assignment works. If I do regular assignment with just 1 plus 1, how do we handle that? 2, yeah, that's all right. 5 x's on the ABC on the right hand side. Okay, that's invalid types. So it's what's happening in that case. So let's see. Eval so there's the left hand side and the right hand side. Okay, yeah, so the left hand side is just the regular integer. What I'll do to simplify things is just I'll set x's to be just a new object and see what's going on here. So it's invalid types the left hand side. So for some reason it's attempting, oh, is it because of the binding? So I'd have to do something like, whoops, like this for the moment, but I do want to make that that binding tighter than the plus. Ah, interesting. So plus is there. So in general, these all want to have fairly tight binding. They don't want to share the, so these are kind of some of the loosest, and I'm probably not using the correct terminology here, but basically we don't want these to bind fairly tightly, but we don't want that to bind tightly, but we do want those to bind, yeah, quite tightly. So what I would probably want to do is, and I want it to bind more tightly than those. So in order of how tightly they bind, these are tighter than those, which are tighter than those. So in that case, I probably want to put them down here, possibly in a new section of their own. I'll just put them here for the time being, just to test. So these will be factors currently. We'll see if this even works. Yeah, well, I didn't make that very challenging. Okay, yeah, so that's binding tightly as expected now. I wonder, does that resolve the issue with the putting it in the other direction, even though that I feel was actually a syntax, like a parsing issue rather than a runtime issue, wasn't it? Oh no, that was a runtime issue as well. Okay, then what I might do, just to keep this commit minimal, I will commit it as is and then fix the binding issue in a second in a secondary commit. So yeah, with all of that said, so I'll keep the old syntax as well, just to hang around just to show that that does work and is equivalent. Yeah, so that works now. What I'll do is, yeah, it's very little code. It's funny. You know, not that it's a complicated feature, but you know, sometimes the like, I mean, it's such a nearly quintessential. But then I suppose it is really just you know, when I was implementing the lookup in general, that was a lot of code, and this is actually just essentially syntactic sugar for that. So so git commit, add method shortcut, or add property lookup shortcut for regular identifiers. For regular names. Maybe I'll just leave it like that. And then as the second iteration of this, I will sort out the binding. I'll create a new section. And this would be a lookup or a operation. They're all operations. So we've a term and a factor, and they're all just generally expressions. Oh, naming things is hard. Expression. Term. I'll call it an application, even though application is quite overloaded, or that would be quite an overloading of application in the context of programming. But maybe for thesaurus. just go with application. So this will now be application, and put those like that. And we're done. So get correct precedence for a certain high binding expressions. Cool. So that's an issue sorted. So that's the object method shortcut and a few bugs sorted. And did I implement anything else? Whoops, where am I gone? Oh yeah, sorting out the bug with function expressions. That's not bad. So next, what I'll go on to is the implementation of this keyword because it will be quite useful, I think. So I'll copy that as test closure. The next bit I'll work on is support for this. Now I won't actually add support in the parser, so it won't be a kind of a specially reserved keyword as of yet anyway. Maybe I'll prevent assigning to it, but for the moment it'll just be a variable in the scope of a function. When a will it always be added to a function? Let me think. It could be so if a function is being called or a method is being called on an object, this will always be an object, and if it's being called on a regular thing, or like if basically if a function is being called and it's not a method, then it can take null, or this could be null to indicate that it's not a method, and that could allow distinguishing the two cases. There probably isn't a need to distinguish the two cases. Again, famous last words, but yeah, without any kind of specific ideas on how it could be used right now, I could foresee it being used with reflection to just for something, but then might that be a bad idea to actually allow distinguishing between method calls and functions? These kind of mechanism, reflection is always going to be abused anyway, and might as well go all in with supporting it. But yeah, I'm probably talking about it too much. I can just get to implementing it. So the idea here, yeah, if I implement some sample code, is to have values, and instead of set, we'll have that, and it'll essentially be the same implementation from that point. And finally, it'll only make sense in the context of a function. So x is this doesn't make sense. Yeah. So so we'll save that. I haven't taken a look at the error handling yet. Actually, that might just be a quick thing to. By default, parse. So this is just a little aside, but by default, parser will stop as soon as it encounters an error. No, it doesn't give anything obvious for handling this. Like I suppose the obvious way of turning the actual token position into a line and a column is to just count the number of new lines encountered, and keep track of the position of the last new line, and then just print the number of lines seen so far plus the column minus or the current token position minus the position of the last new line to get the column count. Controlling the lexer, maybe. I don't want to write it. Okay. Writing a custom lexer, I don't really want to. Like, I probably will have to write the lexer from, or have some kind of update for the lexer to handle the comments properly. But let's see. Okay, location and error types. But kind of sort of declaring it. Yeah, I'll probably do a bit of research on that just on my own time before launching into it in the stream. For the moment, yeah, this is what we'd expect. This isn't currently defined, so let's go ahead and see, can we define it. So it's going to be a purely runtime construct, as mentioned. So the mechanism here, if I recall correctly, is essentially whenever we use the prop notation to look up an item, then we're going to pass the object kind of with that. Yeah, this is going to make things possibly quite, it is going to change things quite a bit potentially, come to think of it. The mechanism itself is, I suppose, relatively straightforward in theory, but maybe not so much in practice. Although what I could do is have a special type of value, which is, oh, I don't like it. It's kind of like the built-in function, but I could have a special type of value which will only be kind of acknowledged by the runtime to basically say, hey, this is a value paired with something else. Otherwise, I need to update all uses of valref. um, to be a value paired with another value, which should always be an object, but yeah, we can just run a simple return a simple runtime error if that's not the case. Hello, Lord MZTE. Glad to have you on the stream. So yeah, that would probably be the not the simplest approach. This certainly isn't going to be simple because the change would propagate throughout the system. But let's see if at least to conceptualize this. So the idea here would be instead of returning a regular v, we'll have a new. Where were we with our previous new valrefs? And oh my god, here we go. So the idea here would be that there we go. I don't think you're supposed to use format bang if you want to make a fixed string. Usually you do foo to owned or foo to string there. Such as in the case of uh, in the case of errors and things like that. Yeah, very likely. I suppose just for context here, the branch I'm working on, like, yeah, there's absolutely rakes of kind of style and kind of formatting issues. Realistically, I don't actually have the clippy linter enabled at this. I'm sure that would highlight all of these kind of things in one fell swoop. However, this is more of a kind of a work in progress branch just to build the features, and then in the mainline branch, I'll be basically adding more cleaner commits, you know, kind of adhering more strictly to like even the naming in some of the areas here. Like there is a proliferation. Yeah, Clippy absolutely would go kind of mental. There's a lot of abuse going on here, but thanks very much for pointing that out. Yeah, keep me on the straight and narrow. So so the intention here is that instead of just returning the value v, we would be returning a new. Would it be a new valref? This is already a valref, so we'd be taking essentially what we'd be. Yeah, it would actually. This is a tricky one actually because the object itself would need to be behind a valref too, so it could be an option valref paired with this value. Yeah, not sure what the best approach is here. Again, I had the mechanism in my head, but maybe hadn't thought through some of the finer details. In the value enum, you can have variants with tuple structs. So instead of bool be bool, you could, in this case, probably should use yeah, kind of unnamed. Basically, remove the names from these guys. Yeah, absolutely. Especially since the names themselves are so poor. I think I did it this way. Um, Partially just because of keeping things consistent. But yeah, absolutely because the names are so bad that it really isn't worth holding on to them, to be honest. Absolutely. Yeah. So anyway, the valref that I'll be carrying around. So essentially will be, so valref currently is an arc mutex of, whoops, of a value. And the idea here is that when we do a lookup of a property, that the value that is being returned from that lookup essentially will, in the background, will have the object it was called on will be paired with it. And so it's, the trick here then is to decide how best to pair those two together. One option could just be to, and maybe even though it would require updating all the signatures for the sake of this feature, might be worth updating this to or might update this to valref across the place. Otherwise, putting it in the kind of nested area of the valref means that we have to nearly unwrap a load of mutexes. So probably better off just pairing these together realistically, even though it does not necessarily pollute, but it will, that change will propagate throughout the whole all the signatures. And this would start off as, and just semantically as well, this would start off as null and then get replaced anytime that there's a proper lookup. And then if there's any other operation performed on, an expression, then that'll get replaced with null again. Yeah, it's a bit painful since the and yeah, I suppose this would be actually an optional, just to maybe make things simpler even. So that'll be an object, so it'll be an optional valref. And then when if an actual call is performed, finally, then let's see, basically what will happen is the args, where are they evaluated here? The args that get evaluated, so each of those get evaluated and then they'll be added to the new scope. At what point are they added to the different scopes? So new bindings are added here. Yeah, and it only makes sense, like, we're not too concerned with built-in functions, because built-in functions are going to be written in Rust. They're not going to be written in the language itself. So basically we'll be pushing onto the vals list. So we'll be pushing this, the name this onto arg names potentially. And if let's see, if expression at this point, how will this get passed? So Lord MZT, another thing is that for errors, it's nicer to use an error enum instead of a string like you're doing in the file on the left. Yeah, absolutely. So again, very, very much work in progress. In fact, yeah, so my typical approach would be to even, I know lots of people as well go kind of have a single error enum for kind of all of their functions as well. I tend to even go even more fine-grained for these kind of things and actually have an error enum for each function just to get very fine-grained kind of error handling. But yeah, like I mentioned, it's very much very much a work in progress. So just to like, I suppose proper error handling, while it would be something that I'm very keen on, is kind of an overhead during development. So so just to flesh out the kind of mechanics and things, just said I'd kind of worry about the errors later really. What's there is a bit painful, but kind of sufficient for the current usages. Uh, I suppose think of them like exceptions at the moment. So the language that I'm making is it functional, declarative, dynamically typed, statically typed, compiled, or interpreted? Yeah, so good question. So it's yeah, for the foreseeable future, it's intended to be an interpreted language, dynamically typed with very simple types, and it is functional or declarative. Well, it's imperative, so it's yeah, it's basically just kind of a C style programming language, very similar to the likes of JavaScript, Java, um, or sorry, JavaScript would probably be the language that is most similar to. It's a bit like Go as well. Borrows a lot of basically borrows a lot of ideas from a lot of modern languages. And the idea is to kind of tie all the fairly, what I would call non-controversial ideas together. So, there are lots of kind of uh, fairly popular language features at this stage that you see kind of repeated throughout a number of programming languages, particularly things to do with object destructuring and sublist notation, like from Python, things like that. Basically I'm just putting into a small minimal language, and the idea is that I'll be using that kind of minimal core to research different syntactic approaches for a more full-featured domain-specific language that I'm uh, intending to basically use instead of Rust, or not instead of Rust, instead of Bash. So to basically play around with syntaxes to create an alternative to Bash that will keep the ergonomics of Bash, but replace maybe some of the weirder, not syntax, the syntax itself is relatively fine, but maybe some of the kind of stranger semantics, and do things like, uh, for example, maybe working slightly better with white spaces, or slightly more intuitively, shall we say, with white space splitting and things like that. Um, Interesting. It would be awesome if you'd make this. And by the way, yeah, at some point I need to put this the chat box just in the stream itself, so I'm not calling it out. But for the moment, this will be fine. It'd be awesome if you could make an embeddable scripting language, meaning that a Rust program can use your runtime as a library, then declare functions and things from Rust, and then execute a script from which can use those functions. Yeah, absolutely. I don't see why not, especially since so maybe not for other languages, but since it's being written in Rust and using LALRPOP and things like that, the calls to the parser and to the evaluator and things like that are being, all of that's being done from Rust. So I don't see any reason why it couldn't be embeddable, uh, somewhat embeddable directly in Rust. What I would say though is that it very much will be a language designed for a specific purpose, which is more or less gluing different programs together in very much in the vein of Bash. So it's going to have ideally make the syntax for calling programs fairly straightforward, but it is for the sake of for the sake of shall we say developer ergonomics, it will be making some compromises potentially in favor of um, developer productivity rather than um, shall we say robustness. So while all programs should be you know uh, still be able to run correctly, what I mean by that is, for example, um, it'll assume that one of the areas that it'll say make compromises in is in the area of error handling, for example. Now, I will be making the error handling in the Rust implementation more robust, but what I mean by in the final language, the idea will be that um, like Bash, it'll be it'll basically no, sorry. Uh, uh, in contrast with Bash, it'll be kind of errors crash the program by default on a failure exit, but it'll have kind of a lightweight syntax, slightly similar to Rust, where you use a question mark to essentially say, okay, instead of panicking, that'll basically be a try catch syntax, which will turn the error into a value plus a sentinel pair, so you can see, okay, what was the error. But the support, the error handling support, because that's kind of, I won't be adding matches and things like that. I feel like those will be, they'd be nice, but they're kind of more than I imagine this language needs. So uh, oh, a question mark in Rust doesn't really behave like a catch. Yeah, sorry, it doesn't. But the Yeah, I suppose it's nearly the opposite in Rust. In Rust, it acts like a throw rather, almost. But in this language, it'll be more like a catch. Yeah, absolutely. So it'll be kind of yeah. The error handling just basically won't be as robust because the idea will be if you're yeah, it's very much for kind of a niche use case. This kind of idea of tying small sets of programs together, and if you were to do the same thing and wanting to do it in a very robust way, or even if you were doing, as again, lots of bash scripts are ideally less than a certain number of lines of code, and the idea hopefully being that if you are going to make something more robust, you probably won't use this language for it. You'll maybe structure it better, or write it in a more full featured language. But yeah, that's the idea at present anyway, that it'll be making compromises in favor of developer efficiency and speed of implementation rather than maybe it won't be as kind of focused on. For example, speed is another thing it won't be focused on. So it's not intending to be inefficient, but because it's intended to be a fairly high level language for just gluing different things together, it's not going to be concerned with being able to do numerical computation and number crunching and uh, twiddling with bit streams. It's just going, it'll be delegating that to other languages, which it will just kind of simply tie together, and it shouldn't be relied on. It shouldn't necessarily be a bottleneck in most situations if kind of used in the appropriate scenario, I would imagine. But that's another compromise that the language will make. Um, Sounds like a neat language. Thanks very much. What's it called, and what kind of interpreter are you writing? An AST walking one or a JIT? Um, so the current language that I'm writing here, which will be kind of a basis for exploring the syntax of the full featured one. So this is called NORPL for not a real programming language. The kind of future language I'll be calling Laurel, so kind of like a laurel wreath. And the interpreter I'm writing now is I'm actually not sure what a JIT interpreter is. Like I know it's a just in time, so it's kind of evaluated just if or compiles just for before it's run. I'm actually not sure what JIT means in the context of the actual interpreter. JIT is an interpreter which compiles the code into bytecode, which is then run in a VM. Oh, sorry, yeah. So there won't be an intermediate representation of this. It'll just be compiled at the moment anyway, compiled to AST, generally faster than a normal AST walk-in interpreter. Yeah, I suppose because it's probably making the code more, like I suppose because it's being compiled as it's going along. Bits of the AST probably don't have to be reevaluated. This one again, because speed isn't a or efficiency isn't speed slash efficiency slash performance isn't a direct goal of this. I'm just sticking with a plain AST walker, but I suppose it's yeah, exactly like you mentioned there. It's more of an under the hood thing where I wouldn't rule out using a kind of converting it to a JIT approach in future. But for now, it's kind of getting just something implemented is the primary goal, rather than kind of focusing too much on any type of implementation. It's more the features that I'm looking forward to using. Yeah. Thanks very much for the questions, by the way. It's really interesting to discuss this stuff. So with all that said, I suppose I'll jump back into a little bit more code here. So what I'm looking at is so values now in general could be passed around with this extra object paired with it to say that, hey, basically it's like I suppose there's no good conceptual name for what this is doing. Like realistically, it's a bit of a kludge for implementing this one feature, and that's kind of one of the reasons I'm not too excited about updating all the signatures to use this to support this feature. And in some ways it kind of indicates, hey, is this the right way of implementing this feature, or is this a feature that makes sense when the implementation itself is a bit kind of eyebrow raising? But at the same time, I think it's probably one of the simpler approaches to implementing it. Well, thanks for joining, Lord MZT. Pleasure to discuss with you, and yeah, please feel free to join again later. Thanks. So yeah, so next, yeah, I just need to consider it in the case here of how this will actually be how this will actually function here. So the idea, or say in the context of the call. So the call ideally at this point will, oops, chair is rolling a bit. So by this point we'll be calling the regular function, and arg names will basically always push maybe it'll just, I don't know, I'll just put this here for now. It's not exactly how it'll be implemented, but it'll always push this onto the end. Vals will also push this, or there's probably a better way actually. So arg names by the end. Oh yeah, in fact, new bindings then could push. It's probably just an array of tuples. So it'll be this and this, and then it's where will this be coming from, and will it be coming from, whoops, so if I, whoa, so if I scroll up, what's even the name of this function? So val expression, and expression is an AST expression. So the only context that we actually have is the current scope and the current expression. So maybe I'll actually hook up my tablet here so that I can maybe reason my way through this a bit. So let's see. So to start with, yeah, when we have an xf, I will say it could have a property called ABC, and then finally that results in a call. So essentially what will be happening here is when this this call gets evaluated, that results in somehow ABC being paired with X in the runtime. So then if for whatever reason, if ABC happened to be called, then X would be pushed into the, will be assigned to the value of this in that context. Then when this call is evaluated, instead that last one gets discarded if it's still being remembered for whatever reason, and whatever value, and again, sorry, this is the value that's in F. The value that's in F, excuse me, is paired with the reference ABC. So then when this call is actually performed on the value of F, ABC is then populated in there as the last, well, it won't necessarily be the last argument. It will, in effect, it'll just be used to populate a hash map, so the ordering doesn't actually matter, but it'll basically be assigned the name this, or it'll be bound to the name this in oh, is the quality of the stream let me see. I might just change my internet connection. Okay, so actually I was going to potentially restart or change networks, but it looks like stream has kind of sorted itself out now. So yeah, back to where I was. In this case, yeah, so we have this whole thing set up. So let me shrink that, and actually I can probably shrink it another bit and still keep the height of the page. And so yeah, how is this going to then, so that's the theory, how is this then going to work? Yeah, accidentally press the stop stream button. So yeah, changing the internet connection there seemed to resolve things. Apologies for the choppy internet there for the last couple of minutes. So yeah, so there's going to be this prop lookup, which will somehow, hopefully, kind of bind a an object to the value it's looking up. So one thing, so I suppose there are probably a few ways that this could be implemented. I suppose another thing that can be done is to, again, none of these really are nice solutions, but we could have this kind of phantom field. Well, not a phantom field because I don't want to kind of conflate terms, but I suppose just this hacky extra field on no, actually, because I'd have to add it for all values. Or maybe I should just do that. So I suppose at some point here, so that's the assignment one. I'm looking for the lookup version. So at some point here, I'm adding extra context to this value. And this this expression returns a valref. And so what could be done is it could be updated to this. And that will be valref plus possible object. Is this definitely the best? just thinking through it and how much destruction it could cause to the code base. Just makes me wonder, is this the best way this can be implemented? But then that does make things a bit clearer in my mind that what would be happening here is the expression that gets evaluated here, it'll be value plus this, and that's where this will be coming from. Only question then is that really what I want to do? Is to add that throughout the code base. Is there a nicer, potentially a nicer mechanism, or either mechanism or implementation? I think the mechanism itself makes sense to me. That and yeah, where it comes from is, I suppose, just for context, to go into the background of this feature and why basically how I've come to this conclusion. So I suppose where to begin? Yeah, I suppose the first was, what's the alternative? And the alternative is basically using closures. And with that, we can, like we saw, we can have state that's accessible by an object and encapsulated by it, so that we can carry that state around with the object. And that works. Maybe that's fine. I There were some limitations, I think, when I was looking at it, like some things that you possibly just couldn't do with that. But maybe not. Maybe I forget exactly what it was. But using this just, yeah, very much gives a much more lightweight syntax. But then the question is how to implement this. Yeah, literally how to implement this, and this in the context of this language um, is different to, say, the likes of Java. With Java, you have a class, and then once you instantiate the class, you can or create an instance of the class, you can have, I guess, a vtable um, associated just with that object. And the methods are defined on that object. The attributes are defined on that object. And yes, Java has reflections still and all that, but I suppose the dynamics are a little I suppose to show maybe some of the I don't know, background thoughts that I put on this. So with the likes of JavaScript or this language, for example, first of all, with JavaScript, yeah, the semantics of this, I'll be honest, I don't understand them. I think it's bound to function scope, which I guess makes sense, but I suppose based on familiar, like, regular language semantics that I'm used to in other languages, um, it's just not very intuitive to me. So how do we get it referencing the object instead? And it is tricky, I feel. I feel like JavaScript probably compromised on, you know, what maybe a more obvious solution would be. But I was just coming from the perspective of, if we have this object X, and uh, we define it to have some function, or first of all we have a value defined on it, and it'll just be a counter function. So then we'll have inc, and that'll be a function, and it'll just go, this val is equal to this val plus 1, and that's all fine. But then, because of this kind of first class support for reflection and functions and methods, and setting function, like dynamically adding methods to objects, what if we had a case where, we just ad hoc created, a decrement function, not even attached to any object. And a similar problem comes up. For example, we could, easily swap function definitions for example, okay, I'll start off with decrement. So we have decrement, and it doesn't actually have locally in the definition. It doesn't have a value for this, but because it's not statically compiled, that's actually fine. And if we then bind it to dec on x, then by the time it is evaluated and we call decrement, that's actually fine as long as this is evaluated in the context in which it's called, if it's actually if this corresponds to x. And it's like that to me is intuitive then. You called dec on x, this is bound to x, even though x wasn't even part of the equation up here. Like this function could have even been defined before x was even a twinkle in the scope's eye. So, and we also get to another scenario where, for example, if we defined y in a similar fashion, and it actually was the basically same implementation as x, and then we just, for whatever reason, we decided, okay, y inc, oops, spelling, y inc did the same mistake again, of course, is equal to x inc, and then we call y inc basically what happens. And like, I suppose that's open to interpretation. It's a, oh, I just noticed that. Oh, all of this time I've been writing and it hasn't, the link has been severed. So oh, that's a big pity. I was basically talking to myself. Okay, I think this does the screen sharing have to be done on the same Wi-Fi network, maybe? Even though it should be on the same Wi-Fi network at the moment. Joys of technology. Yeah, maybe I'll just type it up actually. This tablet isn't synchronizing, so basically to just go over that again, if we have the case of let x and we have, oops, val is 0 and this is just going to be a counter. We have inc and it's defined as a function, and this val is equal to this val plus 1, and then we create y, which is defined in the exact same way, and then we did y inc is equal to x inc, and then we call inc on y. And again, it's kind of a nonsensical scenario, but maybe not this, but maybe maybe there is a desire to define a function using reflection in this way, where it is making use of this. And to me, there is a case to be made for x being the x being closed over in this scenario. But what would it require? It would require kind of a similar mechanism. It would require this prop evaluation still associating inc with x so that x is kind of closed over. But it would then require that closure to be basically, we'd have the same evaluation here, but we're kind of ignoring it in this case so that x will be called on inc. Basically, to keep this I suppose there's a couple of things at play here. The fact that this isn't a statically defined language or a statically typed language or a compiled language means that it's very possible for and the kind of excessive use of reflection, it's very possible for functions to be bound essentially as methods to objects, after the function is defined. And with that, so basically at the point that we define our object, we don't necessarily know what all its methods are and what they're bound to. So because of that lack of information, we can't necessarily bind methods to objects so easily. We kind of have to evaluate the semantics at runtime. And this to me is probably the best compromise to basically say, okay, whenever we have this property access, then we keep the thing that it came, we keep the object that the property came from, basically within our kind of consciousness almost. And then if at the end of a chain of property accesses, then if it results in a function call, then the most recent object that we carried will be added to the scope as this. It's basically the runtime friendly alternative, or a runtime friendly implementation that kind of makes sense to me anyway. I haven't researched it in any great detail. It's kind of just a conclusion that I've arrived at. So I'm not sure how theoretically sound it is, but at least to me makes relatively intuitive sense. It kind of works as I would expect it to. So that's essentially the approach I'll be taking. So with that all said, still comes the issue of implementation. So this is definitely this is an option. This is something that can be done, is to essentially pollute the signature of all of these expression evaluations to take this optional. It could be made more maybe more palatable with a proper type, ref with body, and we could then have option or we could even put it in enum. So val ref with body. Like, kind of one of the biggest issues here is just that you know, it's really only used for one feature, and it kind of changes everything. So though an enum probably doesn't no, that doesn't make as much sense. This is probably, that probably makes the most sense. Another possible, or sorry, could have a struct. So the actual v is the val ref, and maybe we'll call it with this our source. And at that point, it doesn't really have to, like, it will still change a lot, but it's not as ugly as it could be. And it would be val ref, oops, is intended to be used as as a regular val ref would, but it includes does this make sense in the case of if I have something like so one thing I didn't consider is in the case of a property lookup in this way, I'd probably have to do the same thing. Yeah, that's all right. But it includes the most recent object it was referenced from. For example, in the case of x f for field, the val ref is the value stored at the location f, and the source of this value is x. So yeah, maybe that's not too bad. Maybe that's an all right solution potentially, except for the fact that it still changes basically everything. But Is there any nicer way of doing this? Really, not that I can, not one that makes itself obvious to me. Let's see. Like, it would be going into an existing val ref, so the only other option really is to, no, like either it would go into value and I'd be overloading. No, this is, realistically, this is probably the yeah, the most likely implementation at present anyway that I can think of right now. So yeah, with that all said, so yeah, this is one of those features that I'll probably just have to get started with. Make the first, excuse me, type change, and then from that point, just do what the compiler tells me. So with that all said, where was I with this? So this will be this will be a val ref with source. And I'll just take a look at what this will look like in the context of call as well. So this will be a val ref, whoops, with source, and it'll be views value and source. And in this case, this is source. So then, okay, in this case will be, so I suppose by default, all of these new val refs will probably need to just be changed to new val ref with source, and the source will be null in this case, or none in this case. And yeah, that's a good point, is that the options are so even though I said it'd be null, it'd be null, and it'd be easy enough to just remove it from the new scope. So maybe as null in the case where anyway, that's fine as is. That will need to be mutable. And let's see. So this will now be a val ref with source, and the v in this case will be a v clone, and the source will be So expression gets changed to v. Source is locked. So one thing I can do is wait until, so basically return the clone of v here and then wait until I'm out of the lock to actually access source. I'd be very surprised if I'm able to clone the reference to source here, but I'll just put it like that as a theoretical thing. New val refs, those are all going to have to change. New val ref with empty source. Or for now, I'm actually just going to, in fact, it's not even called valref or returning a valref at the moment. So this is going to return a valref with source to do consider renaming to and so this will be valref with source. Oops, not valref. For some reason I had a return there, but v is going to be that, and source is going to be and so at that point, yeah, that's probably all I need to do to get started. 45 errors, yes, that is only to be expected. But I could get through those handily enough. So let's get started with some of the first ones. So we have a new file ref there. And so all of the existing val refs are arcmutex values are going to need to be wrapped. Okay, so let's take a look at line 927. Yeah, I suppose I'll start off by updating a number of these type signatures. Ooh. this hairy stuff. Those don't need to have sources. Those don't need to have sources. Values in scope don't need to have sources. Yeah, it's basically just eval expression could return new potential case. So if we have let x is equal to let x is equal to xf, and then we call f, that should use the binding that got introduced there. So it would need to be stored in the scope, and similarly let x's equals xf, and we go x is 0, and we call that. Yeah, so that will need to be stored with all of them actually. Yeah. So in that case, yeah, those will get updated. Scope will have to be updated too. Evaluate statements in new scope. New bindings. Yeah, those will have sources too. Right hand side could be a value with a source. Okay, so now that I've butchered the type signature, now that I've butchered the type signatures, I've removed one error from the list. That's okay. Yeah, and there's loads of incompatible values and lock issues. Oh, yeah. So a lot of those will be resolvable by just accessing the V instead, I assume. So if I go to 808, for example, and instead of valref with source, doesn't implement debug, it probably doesn't implement. Yeah, so because that's a simple wrapper, I'm calling clone on loads of the val refs, aren't I? So I'll really want to could I just do that, and the clone will kind of propagate down. to the arc mutexes. Should do, hopefully. Does seem to have eliminated a big pile of errors. No method named lock found. Yeah, and so those errors should be resolvable via just the dereference. So 747. If I get 2 fewer errors, then I know that's working. Okay, that's okay. So 699. I have to admit, once I had the mechanism thought out, I was like, oh yeah, that'll, that's, I thought figuring out the mechanism was the difficult part, but it's not. The implementation in this case is actually quite laborious as well. Not seeing many more locks. In fact, I should just scroll through them, but that should be most of them. And then I've probably kind of done more than I should have. So at least the type checker should help me identify if I've gone too far. So 1090, let's see. Yeah, that's one of the cases where I went too far, and this would be another one, I'm guessing. Yeah, because the scope itself isn't. And 839. That's an unknown field. Oh, because I've already decoupled the two. 703. File ref with source, missing source. What's the issue here now? In initializer missing. Oh, because I don't have that comma. 648. Something that I missed. Line 20, global bindings expected. File ref with source. That's an issue with main that I'll have to resolve in a second. 705. Expected enum option, but found. So basically, I need to put that in there. I'll also need to do it for indexing. 98. No, that's main. So eval. Okay, the rest of the issues with main. I probably talked about it for longer than it actually took to implement this. In fairness, Not that not that the code I did was good by any stretch of the imagination, but uh, so can't infer type new bindings. Um, so when I val statements takes bindings, which is a vec of expression, is it? Confusing myself a little here. Okay, yeah, so valref with source. Just thinking now about the parallels of what I'm doing with prototypes as they're in JavaScript, because with prototypes you effectively have two objects. You have the object which is the prototype, which is kind of defined globally, and all, I guess, objects of the same type kind of reference it when they're instantiated from a class. And then you have the object, or the actual value itself, and they're kind of bound together in basically a similar mechanism. So if I was implementing JavaScript, then it would probably be ending up in a similar structure anyway, like different mechanisms, but similar concept of the value of any particular value is going to be bound with another object. Just the actual object being discussed is different in the two scenarios. In the case of this language, then the object it's paired with is kind of the object in the call chain that it came from, or not call chain, but even just property chain that it came from, that the current item came from. And in the case of JavaScript, the object that would be carried with is the prototype for its type. That's an interesting parallel. And it would probably be possible to support both. Yeah, I think so. And you'd be accessing different items depending on the scenario. Although, yeah, that would basically be it. Anyway, I digress a little too often. So, yeah, did I add this type? I did, but it's saying, yes, so that's where the issue I was getting before came from. So this would need to be an expression. Again, don't really want to construct an expression myself. Yeah, and this will be the only place where I'm actually adding that. And it wouldn't be a string, actually, it'd be a var. And I expected a valref with source there, but it got a this. And in that case, let me think. Yeah, it wouldn't make any sense to make it recursive. So in this case, it would be a new valref with source. V is this, source is none. And we'll try that. See if there's any joy. Expect a string. And that seems to be the last. In fact, I can probably remove this type declaration now, but oh no, still needs a type annotation. Okay. So let's go to main. 98 new valref. Those should all be, I suppose, with source. Probably don't need to call it valref with source. I can probably, similarly to the, there's, because it'll be a core concept in the implementation of this language, similarly to, value with prototype is a concept in probably is a concept in the JavaScript implementation. It's probably feasible to give it just a concept. So, there's a name for, like, something carries the meaning of a value reference with its source. But I suppose valref with source is fine for now. Maybe like public. -69. Same down here. Oops, private field. Okay, and after all that, that still doesn't work. So so yeah, let's see what the issue is. So we called so let's just start a bit of debugging. I'll probably aim to end this stream on the hour. So I'll comment out the rest of this file. Okay, and the debugging actually. Oh yeah, so that makes total sense. So I haven't. So if we did it on these guys first. Yeah, there we go. This works as yeah, this works as expected. Um, the issue being that I've only defined that kind of carrying operation on the kind of property access notation. And does that make sense actually? Maybe that's a distinguishing factor of the dot notation, and that this is literally a a special method syntax, and you can't define this methods on on kind of dynamic index accesses. But uh, I'm not going to add that limitation. It's a nice idea, perhaps, to kind of semantically distinguish the two, but in practice, I can absolutely see, again, not that this is going to be a production language, but just kind of treating things realistically, that if I came across that and I was like, in fact, I had enough confusion about, why are there two ways of, accessing a property in JavaScript, kind of two equivalent ways, and yeah, adding subtle differences between those two things that effectively achieve the same thing, especially when one is generally just sugar for the other. I would see that as being, being very amenable to trip ups and gotchas. Um, so we'll take that and we'll add it to indexing. So this is index binding, this is index accessing. And well, that's interesting. Do we allow the same for x's? So if x's is an array, no, we don't do the same thing, because you can't, because on an array you'd be doing this dot zero, and it doesn't make sense for a couple of reasons, but interesting thought experiment at the same time, I think. Oh, and I should update the syntax of that, because I changed how that's laid out. And there we go. And there. So then if we go to test, not found in source, let's see, 677, Source not found in this case. Yeah. It turned out as well that even though I am in the locked V, I didn't have to come out of it again. Property name not found. Why is it printing all of that? Am I printing that in the I'm not sure. Oops. So print x's has a, oh yeah, it's being printed with its source. Yeah, of course. These debug logs are going to would be quite hairy with that, with all that extra information. So what I'll do is I'll go back down here and update the print so that it only prints the actual value and not the paired source. I hope that I can do that. So line 60. So I have these. So what I'll do, that will panic if it'll panic if there are no parameters, and it'll panic or it'll ignore any extra ones, but it gives us what we want. So yeah, that's as expected. And let's see how the rest of it goes. Property name not found. Yeah, that is nice. So that works as expected. So now, yeah, adds support for this has been added, and that was quite often with these things a lot trickier than I had in my head. That's the joys of doing this stuff on the fly without properly thinking about how exactly how you're going to be implementing it. But worked out in the end, and actually wasn't quite as like I did have to modify a bunch of signatures and things, but on the whole, the you know, there probably wasn't as much needed to be changed in the code as I possibly would have expected. Now the code is very looking very shook now after this latest iteration. I'll have to keep that in mind when I'm doing the mainline branch, but at least it is implemented. That's nice. So with that said, let's see, do git status. Yeah, do I have to go? Do I have to bear witness to the atrocities that I've committed? Yeah. Why are you making me confirm all of this git patch? I know what I've done. I said I'm sorry. Maybe I haven't said I'm sorry. Am I sorry? Who knows? Add support for this. Yeah, that's enough. Okay. There are almost 15 minutes left in the hour. Of those two ticked off. How about quickly, hopefully for dessert, implementing a for loop over objects. So we go for k v in, so let x is equal to a is equal to 1, b and c are equal to 2 and 3 for k, v, and x. Print k, print v. Do I have concatenation in this language? I actually can't remember. Again, excuse me. Yeah, iterator must be a list. But one of the many things that I'm not sure if I've implemented or not. But anyway, so we'll go to the for loop section. Iterator no longer has to be a list, but it must be a list or object. I suppose I haven't used those backticks on any of the other keywords in any of the other error messages, so I'll leave it off for now. Value list. So instead here, if I have an object of props, and instead I can probably do Rust iterate, and classic example of, well, I'm not sure if it's a classical example. I haven't read the implementations of many other interpreters, but I would imagine that a lot of interpreters do just use the underlying mechanisms provided by the language. So I can just use for key value, possibly, in props. Yeah, in this case, the value will be a string always, and the string will be key. The value then will be, or the second value, which will be a new val ref, which is in reality a new val ref with source. Will just be value actually. And new bindings. What's that doing? Oh yeah, so it's where is LHS being defined? Yeah, so it's binding the this new list to whatever left-hand side the developer has added, and that would more or less be the same. So let's take a look at that. What? Oh yeah, for key value in props. And 2 to 6. I expected a string, found a reference to a string. I won't do an int iter. Yeah, I'll just clone it. and found a mutable reference to a valref with source. So that's probably a similar matter. Oh, this isn't a that's not a structure that I'm constructing. Invalid types, interesting. So what is, oh yes, because so maybe I haven't implemented string concatenation, and that could be something. If there is again another few minutes in the stream, I could try that next. Print k, print v. Yeah, and the order is unspecified, but they're printing in the correct pairs. And similarly, if I printed them out as their pairs, that's possible too. Yep. So that's has support for iterating objects. And let's try adding support for yeah, plus is just the standard I seem to have support for oh, it's because I'm trying to convert the integer to or I'm trying to add a string with an integer. It wasn't that string concatenation wasn't supported. So yeah, eventually I'll need to add casting of some kind. Probably won't do it in again this research language. So yeah, with that said and done, that is basically what I'm looking to have done here today. So let's just take a look at the to-do list again. So I have flow object enumeration done. I've done the method called shorthand for objects. Haven't done the sub list today, decided not to do that. Added support for this. And yeah, so so the last few bits of these trickiest ones with array sublists should be fairly alright. I should be able to even just use Rust's implementation of this as well to even save myself some more hassle. String enumeration and string and substrings could be tricky just because I have to actually put thought then into what's it called? how exactly to how to represent strings, because they probably will be byte strings as opposed to um, Unicode strings in representation anyway. And that is one area where I'll be diverging. Um, where I'll be diverging from Rust implementation. So I'm actually going to split this up because I won't actually do all of this. In fact, I think I'll actually leave out the string stuff um, before. So I do want to start. So again, for anyone who's been watching the whole stream, I was discussing how this is currently a research language that I'll be using to research different kinds of syntaxes for this this kind of more full-featured, I suppose, or more robust language called Laurel that that will be kind of a Bash competitor, I suppose. And I suppose I did want to get this kind of core set of features done before I kind of dove into um, messing around with the final syntax. Um, but I don't need to have all of these features done. And I'm just thinking, I don't need string enumeration. Confirming evaluation of keys, that's more kind of a demo, I think. So that should be all right to do in one session. Else, if could, to me, looks like it'll probably be one of the trickier things to implement. And then destructuring, I'll remove that because it's a little distracting. I'll just put it down here. Prevent reassign, and these two are kind of related. Prevent reassigning the same name more than once. That has to be done for lists as well. Probably not essential to do before I start researching this or doing the next phase of research, but shouldn't take too long, I don't believe. But yeah, with those all said, that is yeah, basically the only stuff I won't be doing that I noted before will just be the string stuff. I'll move on before then. Hopefully that won't bite me with regards to the syntax research. But anyway, that's a story for another day. So yeah, sorry, I was getting a little hungry there in the last while, so I was probably um, ranting or kind of digressing quite a bit. But thanks to anyone who was watching the stream and chatting with me and everything as usual. So yeah, thanks very much for tuning in, and I'll see everyone next week. Thanks very much. Bye.